an astronaut's favorite candy? A Mars bar. I'm Skylar. I'm getting my PhD in astrophysics, and this is Atlas. He will be causing distractions. This summer, I am doing a series called Astronomy 101, where I'm going to walk you through our universe and what we know about it and what makes it up and all sorts of fun stuff. Today is just the introduction. What is out there? What is everything that makes up our universe? What does it look like? We're going to see a bunch of pretty pictures. We're going to talk about some general timelines and scales. It's going to be great. So let's get started. Oh, what is out there? Here is a list of all of the primary things that make up our universe. You have planets, you have moons, you have asteroids and comets, you've got stars, and there's a whole bunch of different types of stars. Stellar remnants, of which there are a whole bunch of different types. You got white dwarfs, neutron stars, black holes. You have galaxies of different shapes and sizes. You have dark matter, you have gas, you have dust. You have so much out there in the universe, and today we're just going to talk briefly about each of these main things. Let's start close to home with planets. We are on a planet right now. Earth is a planet. Now, according to the International Astronomical Union, there are 3 things you have to do in order to be considered a planet. 1, you have to orbit around the sun. 2, you have to have enough gravity that you have a roughly spherical shape. And 3, you have to have cleared your area of any other debris or any other objects. And it is this last point that led Pluto to be demoted, because Pluto is in a region called the Kuiper Belt, which is a lot like the asteroid belt. It is out past Neptune, and there are tons of objects out there by Pluto. Pluto does not have gravitational control of its region, so they figured they can't really call it a planet. When we take Pluto out, there are 8 planets in our solar system. In order going out from the sun, you have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And yes, I will be saying Uranus and not Uranus. This is just purely so that I can keep a straight face. We split these planets into 2 different groups based on their characteristics, because you might notice that there's kind of a separation between the inner solar system and the outer solar system. Planets in the inner solar system are what we call terrestrial, or Earth-like. These are smaller, they are rocky, they have a surface that you can actually stand on. Compare that to the outer planets, which we call Jovian or Jupiter-like. These are gassy, they don't have a solid surface, and they are much, much larger than any of the inner planets. We'll go more into detail on all of these planets later in this course, but for now, I just wanted to remind you of their order and tell you that we have a couple different types. Now, these planets that we just talked about aren't the only planets out there. We have discovered over 5,000 exoplanets. Exoplanets are just planets that are not in our solar system. They are planets that orbit around another star. We are discovering more and more of these every day, and they come in a large variety of shapes and forms. There will be a whole video later on just about exoplanets because there's a lot to say about them. For now, let's come back to our solar system. You have the 8 planets, and then you'll notice that there's a bunch of little things orbiting around the planets. We call those things moons. To be considered a moon, you just have to be in orbit around a planet. Now, not every planet in our solar system has a moon, but most do, and most actually have more than one. In the inner solar system, the 2 planets that are closest to the sun, Mercury and Venus, have no moons. Earth has our moon, our singular moon. We see it all the time. It's gorgeous. Love it. Mars has 2 moons, Phobos and Deimos. And this is one of my favorite images / videos of these moons ever. This is a solar eclipse from the surface of Mars. That little potato looking thing is Phobos, one of the Martian moons, passing in front of the sun as it goes around the planet. And I love it. I love it. I'm in love. What can I say? When we get out to the outer solar system, all of a sudden there are way more moons orbiting these giant Jovian planets. Jupiter has at least 79 moons, and Saturn has at least 82. Uranus and Neptune have slightly fewer, with Uranus having probably about 27 that we know of, and Neptune having 14. That's still a lot. Now, besides planets and moons, there's a lot of other stuff in our solar system. You have asteroids, which are these objects that are typically much smaller than a planet, and most of them are found in the asteroid belt, which is a region in between Mars and Jupiter. There's thousands of these objects out there of varying sizes, and most of them are in a pretty stable orbit. You also have comets, which are objects that are on a very elliptical orbit, which means they go from very far away from the sun to very close to the sun. These comets are made of both rock and ice, and when they get close to the sun, the ice on their surface heats up and turns into a gas, and that's why you get such beautiful tails like this coming off of comets. If we start to zoom out, now we have to talk about larger objects like stars. Our sun is the closest star to us. The next closest star is 4 light years away, which means that it takes 4 years from light from that star to get to us. Light does not travel at an infinite speed. It travels at 3 × 10⁸ meters per second. And this is a really important fact that you're going to have to keep in mind as we continue this course, because light not traveling at an infinite speed has a lot of interesting implications for astronomy and the universe. So what is a star? A star is an object that can fuse hydrogen. It can take 2 hydrogen atoms and combine them and make a helium atom. That's all you have to do in order to be a star. But in order to do that, you have to be really, 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 really hot. And in order to be really hot, you have to be really massive. 80 times the mass of Jupiter is about the limit where we can start to fuse hydrogen. But there's actually an upper limit to the mass of stars too. Really, really massive stars have tons of pressure. They are so hot in their core that there's a lot of force trying to push stuff away. And so the most massive star we think can only be about 150 times the mass of the sun. So stars are these objects that can do hydrogen fusion. They are made of gas, and they range from about 0.05 the mass of the sun to about 150 times the mass of the sun. There are a ton of different subcategories of stars, and we will talk about that further on. But one thing that's important to know is that stars don't live forever. They are born, they go through a life cycle, and then they die. And when they die, you're left with objects that we call stellar remnants. And these are some of my favorite things in the universe because they do really interesting things, and they exist in very extreme conditions. Why, hello. Stellar remnants include objects like white dwarfs, which is what our sun is going to turn into. White dwarfs are made primarily of carbon and oxygen, and they are so dense, it's like fitting the entire mass of the sun into a ball the size of the Earth. Another type of stellar remnant is called a neutron star. A neutron star is, as suggested, primarily made of neutrons and supported by neutron degeneracy pressure. Neutron stars are so dense, it's like fitting the entire mass of the sun into a ball the size of the Isle of Manhattan. What? Yeah, ridiculously dense. The most massive stars can even turn into black holes, which are a region of space so dense that not even light can escape their gravitational pull. And we will talk about them plenty more going forward, I promise. So you have these kind of main things that a star can turn into, and you often see them inside these beautiful regions of glowing gas that we call nebulas. Nebulas are just a region in space where you have a lot of gas and dust, and we find them at the end of a star's life cycle, like this, which is what we call a planetary nebula. It's a white dwarf surrounded by the outer layers of the star that got pushed away. You can have something like the Crab Nebula, which is a supernova remnant and has a little neutron star in there. Or you can have nebulas that exist where stars are being formed. So this is an example of a nebula that is birthing stars. It's called the Orion Nebula, and it is gorgeous. It's one of the regions where we have very, very big, bright stars, and so they are illuminating the gas around them, which is making it glow in all these pretty colors. If you want to see some of the most beautiful images of objects in the universe, just do a quick little Google of nebulas. Now, if we continue to zoom out, all of these things, the solar system, nebulas, stars, we find them inside galaxies. And galaxies are just a gravitationally bound region of all of this stuff: gas, dust, stars, and dark matter. Dark matter is simply matter that doesn't interact with light in any way, shape, or form, and we'll talk about that a whole bunch going forward. But It's one of the big mysteries of the universe because light is the primary way that we do astronomy. We need light to see what is out there, and if you have something that doesn't interact with light, we just can't see it. Galaxies come in all sorts of shapes and sizes. The one that we are in is called the Milky Way, and it is a spiral galaxy. We are out in the arm of the Milky Way, as you can see here, which means that when we observe the Milky Way, we are seeing it edge on, so it just looks like a nice little line through our sky. In reality, if we were to zoom out and move out of the plane of the galaxy, we would be able to see all these beautiful spiral arms. There are loads of spiral galaxies out there, but they're actually not the most common type of galaxy. The most common type of galaxy are ellipticals, which look like this. They are kind of boring, I'm gonna be honest. They're not as pretty as spirals. They don't have a lot of structure, they don't have a lot of star formation, they're just sort of blobs of red and yellow stars. But they're important in their own right, and we'll get to that. I actually do some research that involves elliptical galaxies, so maybe I shouldn't be so dismissive of them. These are really the main things that make up our universe, from the very small scale things that make up our solar system all the way up to galaxies. Now, let's give you a sense of how big some of these objects actually are. Something that I find to be kind of a fun analogy is just talking about distances. So if we consider a single grain of rice to be about 10,000 miles, that means about 2.5 grains of rice is the circumference of the Earth, which is already a pretty large distance. How many of us have actually gone all the way around the Earth? But we're gonna visualize that with about 2.5 grains of rice, so it would take up about this much space. To get to the next nearest star, not the sun, but the nearest star, Proxima Centauri, that one that is 4 light years away, that is the equivalent of filling up my entire bedroom with rice. You need that much rice to just get to the closest star. To get to the closest large spiral galaxy, Andromeda, pictured here, she's one of my favorites, you would need to fill up this building, the NASA Vehicle Assembly Building, which is one of the largest structures in the world. You would need over 7 of these buildings full of rice to get to the nearest large galaxy. There are billions of galaxies out there. To get to the closest one, you need 7 of these buildings filled with rice, where each grain of rice is 10,000 miles. Space is really, really big. Now, before we wrap this up, I also want to touch on the fact that our universe is really, really old. We think it is about 13.8 billion years old, and we'll talk about how we get that number later on in this course. But this means that we can think about the timeline of the universe. You have the Big Bang, which created space and time as we know it, and that happened 13.8 billion years ago. Our own solar system and the sun and all the planets formed around 4.6 billion years ago. So there's about 8 billion years worth of universe that our own solar system didn't exist in. Now, civilization as we know it is only a couple of thousand years old. So compared to the entire history of the universe, we are quite the insignificant blip in both space and time. But I'll be honest, that's one of the things that I love most about astronomy. When I look up at the stars, I remember just how tiny we really are and how insignificant our problems can be. Although I also love astronomy because it makes me feel important. It gives me a sense of place in the universe, a feeling that I am a part of this larger, incredible structure full of all of the beautiful and mysterious objects that we talked about today. I hope you will join me as we talk more in detail about all of these amazing things that make up our universe. It's going to be a really fun adventure. Next week, we're going to talk about how astronomers actually observe the universe. How do we know what we know about objects? We're going to talk about how telescopes work. We're going to talk about spectroscopy and light and imaging. It's going to be cool. There'll be lots of pretty pictures too. So if you are excited to learn about space, please hit subscribe, share, comment, like, send it to your friends. Join me as we discover the universe together this summer. I'll see you next time.